And here we go. Venn diagrams. There are 4 key regions that you'll need to visualize or answer. And once you answer them, it's much easier to answer the rest of the questions. Yeah? On the back, can you flip over to the back blank of your sheet? I want you to draw this in. Draw a Venn diagram with a rectangular box here. Draw a Venn diagram. 1, 2. Call one A, call the other one B. Okay? Now, I'm going to color 4 different regions because they represent the commonality of these different regions. So here we go. I'm going to color this in blue. So just the only bits in A. You see only the bits in A, nothing to do with touching B. I'm going to color where A and B overlap as yellow. So that's the second region. And then you've got where B only occurs. So it's in red or pink. And your last region, let's use, what other color? Purple. Purple is everything outside of B and A. That's 4 different colors that I've used. Those are 4 different regions that will help you solve problems if you can identify which regions you have. So, copy this down for now. You may not understand what they mean, but I want you to write here, so label the yellow region as A common with B. So A and B has something in common. This region, that's in pink, it's when A complement, out of curiosity, anyone remember what does complement mean again? Excluding. So you can see outside of A, so when we say A, this is A. When you say A complement with a dash, it means everything outside of A. So everything outside of A in common with B. Okay, so everything outside of A that is also common with B is only this region here. That's the only bit that's in common. This blue region is known as A common with excluding B. So everything that's outside of B that is also part of A is that region. Sometimes the languages, which I'll give you a layman's term for it so that you understand it easier. But the last one there is not A, let's say excluding A, common with excluding B. Okay, so you got 2 there. Excluding A, common with excluding B. If you have a different color pen, this could help you. So, when you're doing Venn diagram problems, how do you know which regions is which? The way I normally explain to students is I say, this is where A and B, so in the yellow region, A and B have in common. This is where only B occurs. This is where only A occurs, because you can see in the diagram only A is colored. B doesn't get colored. Over here, only B is colored. A is not colored. Here, both A and B is colored. Whereas over here, both A and B is not colored. Okay, so right here, not A and B. That might help you as we're answering the questions. When we flip back to the page, you'll be able to see the 4 regions. Boys, that shouldn't be there. If you're not going to use it and you're not going to drink it appropriately, put it outside. Thank you. We're going to write notes of actively taking notes. Yeah? Or actively listening. It's one of the 2. All right, here we go. You got your 4 regions. So remember, these words might help you. So only B, where A and B occur, where only A gets colored, or where A and B doesn't get colored. Okay, so those are your 4 key regions. Now, let's take an example. Going back, flip over. Let's look at this example here. You got 26 students in a class, okay, which generally in a full class, you do have 26 students in a class. Now, if you know that 15 students like maths only, okay, so they don't like any other subject, they only like maths, right? You know there's 15 of them. Then there are 9 students who like maths and English. These 2 dot points become a problem for a lot of students because in the realm of maths, the students who like maths, there are some students who only like maths, and there's 15 of them, right? But then there are 9 students who like maths. Now, out of those 15, I don't know if that 9 and the 15, is it just 9 exclusively, or is it just both 9 and the 15? Does that make sense? Because that 9 and the 15, one likes maths only and one likes both maths and English. So it makes it confusing on how many students truly like maths as it is. That's why when you draw a Venn diagram, it makes it a bit easier to solve. Okay, so I'm going to teach you how to extrapolate it. Now, the next bit is 4 students who don't like maths or English. Now, the 4 students are easy because if you don't like maths and you don't like English, let's say this is maths and this is English, the 4 students have to not belong in either maths group or English group. So you got 4 on the outside. That's where not maths and not English. So the notation for that is maths common with not English is equal to 4. Okay? Then we take our information, 15 students who likes maths only. Now the key word was the only part. So this means they like maths, but it's in common with not English. They don't want English. That region is 15. So I know this is the number of students who like maths only, but do not like English as well. Then you have your second line, 9 students who like maths and English. That's a cross between the two. So because of that, maths and English have something in common. We then know that must mean 9 fit in. They're still in the maths region, but they're also in the English region. So if I asked you now, how many students in total like maths? What would you say just from the diagram? 15 for only maths only. But if I said maths in total is 24, because these people, they are still people who like maths as well. So in total, the blue and the yellow region make up the total for maths. Now what's special is that once you know that, you can then figure out how many people like English only. Now let's think about it. Right now, 15 plus 9.
6.
15 plus 9 is not 6. 20. Oh, but you're saying the leftover. Yeah, but keep in mind, 24. But remember, there's 4 students who don't like maths and who don't like English as well. So in total, that's 15 plus 9 plus 4 students. That's 28. But there's only 26 students. So what's going on? There's a problem here.
6.
Because you count all the people in the like bedroom, so you have to
That's sad. That's
subtract 26 to equal the number of people who are in it.
Say that again. So you're on the right track there. So can you see the problem when I draw it? This is the most common mistake that students generally make when they answer this question here. So how can you have 28 students when clearly we only have 26 students? There was a problem there, right? So where had the problem occurred? The problem had occurred, like I said again, that 15, yes, it's maths only. So definitely this is 15, right? But when I say 9 students who like maths and English, right? Where does that 9... I don't know why this is happening. This is so annoying. That 9, remember, we have a total of, if we add 15 plus 9 plus 4, that gives you a total of 28, which is a problem. So what do you have to do, Carissa?
Or you have to subtract 26 because there are 26 students, and then that will equal the number of people who have English only.
So if you add them all together now, if English only is only 2, because 28 take away 26 is 2, how many goes into maths and English then? Oh. Here we go. In example 2, there's a group of 30 students. It is found that 10 play both cricket and soccer. So we've got cricket, we've got soccer. So we can use letter C for one circle, letter S for a second circle. Because they said, all right, Mateo, can I have you outside for a moment? Thank you. And Xavier, you're going to be next after Mateo comes back in. All right, so in this example, we know that 10 play both cricket and soccer. So that means for both cricket and soccer, we can say that there are 10 people. Now, I like to use the two-way table to do calculations, and I like to use a Venn diagram to visualize the problem. So here, how do you set up a two-way table? You use the events that you have. So you got C and you got S for soccer. If you have C, then you also have not C, meaning people who don't play cricket. And then you also have soccer, then that means there is also not soccer, so people who don't play soccer. Yeah? You got C, C dash, S, and S dash. When they say 10 play both cricket and soccer, this box over here represents who play both cricket and soccer together. Okay, so soccer and cricket occur at the same time. So that's what's in common. So each one is the commonality of each box. So therefore, if I fill it in, I know there are 10. This is really frustrating. What's happening? All right. There we go. So you got 10. Now let's have a think about it. They say there are 30 students in total. So this bottom right corner represents total. Xavier, I'm over here. And the more you look that way, you're giving him attention, so he'll keep doing what he's doing. So it's not helpful for me. Does that make sense, Xavier? It's the same for you, Hamza. Cool? So you two, this way. Then it'll get tired. If you keep feeding it, you're going to be next, and I'm going to say the same thing for the next group. Yeah? Here we go. Next question. We know that there are 30 students in total. So here we know that in total there should be 30 students, and it should all add up to 30. So one of the nice things about two-way tables is that they all add up nicely, or mathematically it should all add up nicely here. Next bit. They say 5 play only cricket. So with the regions that we have, this is cricket. That's cricket and soccer. But if you only play cricket, that means soccer shouldn't be included. So this is the region for cricket only. This is cricket only in this spot here. So to fill it in, we can then say this must then be 5 students play cricket only. And then they say 7 play only soccer. So if you look at the soccer row, this is soccer, but that's soccer and cricket. This is soccer with no cricket, so that must be soccer only. So if you fill in soccer only, with the table, you can now actually calculate all the numbers. You can work them out. So let's work them out individually. How many people play cricket in total? 15. So there are 15 students who play cricket in total. But then how many people, if you look crosswise, how many people don't play cricket? 15 as well. Because if you've got 15 people who play cricket and there's a total of 30 people, there must be 15 left over that don't play cricket at all. Yeah? But then once you know that is 15, well then that means you can work out how many people don't play cricket and how many people don't play soccer. Since you know, out of people who don't play cricket, there are 7 of them who play soccer. So how many people don't play cricket or soccer? 8. Very good. So this one must be 8. But once you know that this is 8, you can actually work out how many people play soccer and how many people don't play soccer. So let's add them all together. 10 plus 7. 17 people play soccer. 5 plus 8, which is 13. And you can see that 17 plus 13 does give you 30 as well. So the two-way table is great for calculations. Venn diagram visualizes that. So if I just gave you a two-way table, it's hard to visualize what's happening. But if I now put the numbers into the regions, I want you to see where the numbers actually end up. Remember the 4 regions I gave to you before? Here's your 4 regions. This is where the 10 is. This is the region of blue. That's one region. Then when we said soccer only, and not cricket, this is where soccer only is, and you don't include cricket at all. So that must mean 7 is in this region. Which makes sense because if you look at the circle of soccer, how many people play soccer? You've got 10 plus 7 is 17. It makes sense. So the blue plus the yellow region gives you all of soccer. Then, if you looked at, what about people who play cricket only, but they don't play soccer? So if they don't play soccer, they play cricket. It's cricket only. So that means in this region, that's 5. So you can see here, 10 goes here. That's the commonality we're seeing between cricket and soccer. Cricket only, soccer only. And then your last region, which I'll color in, I'll do gray. That is everything on the outside that is not cricket or soccer. We should have 8 people. So on a visual aspect, most students, when they first look at the two-way table, it doesn't tell you a lot easily. But if you look at the diagram, it's much easier. If I said how many people play cricket, you can look at it and say 5 and 10. If I said how many people play cricket only, you can say 5. If I said how many people play soccer only, you can look at it and say 7. And then how many people don't play any of those 2 sports? 8. Now if you add all the numbers together, it should add up to 30. So let's count them. 10 plus 8 is 18. 18 plus 7? 25. Good. 25 plus another 5 is 30. So this Venn diagram represents what you have in here. So what am I trying to teach you? Those 4 regions, those 4 little boxes, will help you visualize the 4 regions in the Venn diagram. So arguably, out of the 4 exercises, exercise 8J is one of the harder ones because if you're putting them in the wrong spaces, you'll get the wrong answers. Okay? Sorry, Mateo, I was going to speak to you outside, so can I have you outside for a moment? Thank you. What I want you to do now, so now that I've demonstrated the first example that actually worked out, the numbers actually worked out, I want you to have a go now answering these questions below because you've got all the information in the diagram and you've got the two-way table. I want you to find me how many people play neither cricket nor soccer. How many of the people surveyed play cricket? How many people surveyed play either cricket or soccer or both? And then what's the probability of selecting someone who plays soccer? Okay? So that 4th one there is really what you want to work on, but the diagram should allow you to answer those 4. I'm going to come back after I speak to Mateo, and then we can check our answers, but that's a J. Okay, the other rest of the session is going to be for you to work on a G, H, and I. I'd say J is probably the trickiest one at the moment. Okay? I'm going to pause the video. All right, team, let's see what you got for your answers. Let's call a couple of students. Let's start off with, who can I pick? Let's go with Willem. Assuming you did this question. Example 2A, how many people play neither cricket nor soccer? Sorry? 8 is correct. Give yourselves a tick if you got that right. B, let's go with Attila. How many of the people surveyed play cricket?
It's here. What the hell is it? It's one of the 15.
15 is correct. We can see cricket is this column, so the total number of people that play cricket is 15, not 10. Some students confuse it with 10 for cricket or 5 as a 5 only, but it's total number of people that play cricket. Next one, C. What did you get? Let's go with Zara. How many people surveyed play either cricket or soccer or both? Now that's interesting. So cricket, you've got 15, or soccer, which is an extra 7. So 15 plus 7 is 22. And it said or both, which is literally both of these. Okay, so both purple, blue, and yellow. So in total, yes, it should be 5 plus 10 plus 7. This gives you 22 people who play cricket or soccer or both. Okay. Then the last one, this is where you actually now apply probability. So what's the chances of selecting someone who plays soccer? Can I please have Hamza? 7 over 30, did you say? All right, let's see. So what's the probability of selecting someone who plays soccer? Well, soccer is this group here. How many people play soccer in total? Oh, sorry. I realize it's on freeze. We've got a total of 10 plus 7. 17 people play soccer. Or if you look at this diagram, there's 17 people who play soccer out of 30. So therefore, your probability should be probability of people who play soccer is 17 out of 30. If they said how many people play soccer only, then saying 7 out of 30 is correct. But because they say play soccer, there are some people who play cricket and soccer as well that you have to account for. That's why it's 17 out of 30. Hands up if you got all 4 correct. All right, well done. That's really good. That's 8J. Okay, so 8J is about working with Venn diagram. Two-way table really helps you calculate. And the aim is to work on questions like D. Okay, so D requires that you need to be able to read the diagram to then answer the question. Okay, I'm going to stop the video there, but this